Welcome to Useful Programming Tutorials. Today we're going to be going over how to make a basic Tic Tac AI with Python. Now, normally a Tic Tac AI would just be hard-coded, so it would choose the correct move. However, this one will learn. So basically what that means is this would be useless in a practical situation. However, we're going to build on this tutorial with Chess AI and probably some other ones as well. So this is just going over the basics of how to create an AI that learns. So the way we're going to do this is we'll have an AI class, so we can create two different AIs which can play against each other and learn from what moves they make and how good those moves are. So we're going to need a way for the AI to learn, and we will do this through a reward and punishment system. So this means that when an AI makes a bad move, which may cause it to lose the game, it will be punished. So that will set a value for that move to a lower value. And if an AI wins from a move, the value will be set higher. So the AI will also choose a move based on that value. Eventually, once the AI learns what is a good move and what is a bad move, it will be able to play tic-tac-toe optimally. To get started, we will import random. This will allow our AI to make decisions randomly. So then we will create our AI class. In the init function, we will pass in player, and player will be either O or X. Also in here we will have self.actionValues equals dict, self.newValue equals 0.1, self.player equals player. So self.actionValues, this will map the state action pair to a success rate and times pair. So state is just a representation of the board before the AI makes the move, and it will then be mapped with the action that the AI has taken on that board. So that will be mapped to success rate and times pair. So the success rate is just the average of all the rewards and punishments from that move combination of the state and action. And the times is used to keep track of the number of times that that move has been made on that board, which will be used to calculate the average. This new value just means that every time a new action happens, so let's say the AI hasn't done a move before, it will be set to 0.1, so that would be quite low. The average success rate should be around 0.5 because there's two AIs and they're the same, so they should each win about half the time. So self.player, again, that's just either O or X. So now our first function. So this update Actionval function will take the outcome of the game along with the state and the action. It will then update the success rate of the action, which happened with this state and this action here. So it goes into action values and it accesses this state and action, which we've passed in, and the first value of that. So that will be the success rate. And here we just calculate a new average. This next line, all that does is increment the times the action has happened in the action values dictionary. I'm now going to write the choose action function. So obviously this needs state just so the AI knows what actions it has available to it. We've made an array to store the actions that the AI can take. So this for loop will look at all the actions that the AI has taken in this state previously, and it will add it to actions. This next piece of code will go through each space on the board, and it will check if there is a space there. So if there is a space there, it can put an X or a 0 depending on which player the AI is. And if you see this act, this just stores the row in the box. What this line here does is a lot of stuff. Well, it uses a self.rotate function, which we will write in a minute, and it will rotate the board 90 degrees. And if you think about it in Tic Tac Toe, it doesn't matter what the rotation of the board is, because you could have one board which is maybe, well, let's say 3 X's on the top row, and then the X would win the game. Then you could rotate that 90 degrees and it would be 3 X's on the third column. But that's still basically the same board, and the AI does not really need to differentiate between each different rotation of the board. So this line here, all that does is make sure that the AI hasn't done this action, or hasn't done the equivalent of this action. And the reason we're making sure that we have less actions is because it will make the AI a lot quicker to learn. So then we just add it to the actions list as a new action that the AI could possibly take, along with the new value, which is just the default value for a new action. Yeah. Now that I think about it, we probably need to change this line here where we have the action in self.actionValue.keys, because we could potentially be looking at the same state but just rotated. So we will add a similar code to what is down here. So you can now see what I've added here. This is just basically the same thing as here, but with if statements. And it will just check to make sure that we haven't done this action before, but in a rotated version. So here we're just going to add up all the success rates of the actions so we can calculate a random action. Here we choose a random action, so we have this random number here, 0 to total, and total is the sum of the success rates. So by taking off each of the success rates until the num is less than or equal to 0, we will get a random action that our AI will take, and then our AI will return this action. So something we need to do up here, we have to make sure that this one here is 0, and here, because rotate will return a action and a state, but the action will be the first one it returns, so we have to put 0 here because it's the first value. And here we put 0 at the end, and 0 at the end here. So our choose action function is done now, and we will begin to write the rotate function. So all it needs is a state action pair as input, and from that input we are going to get state and action using the indexes 0 and 1. So new board will store the new rotated board, and what this code does is just change the layout of the board to 90 degrees. So we'll have a comment here showing the structure of the board. So we might have 0 or O, X, O, and maybe minus, minus, minus. Minus denotes a blank space, and an O, and an X. Now that game would not happen, so I'll just put another X here. Bit random for now, but this would be in a 2D array, so this would be stored like this. To board it would be, and then in the first array here, that would be the first line, so OXO in here, and then -x in here, and OOX in here. The new board will be the 90-degree rotated board, and new act we will set to a tuple because that is the way we're going to store acts or actions. So we're going to have these if statements, and this is a lazy way of just changing the action and whatever it's supposed to be. And I did spell act wrong there. And now we have the 90-degree rotated act and the 90-degree rotated new board variable. We can just return these as a tuple, so new board and new act. So that will conclude today's tutorial, and this series will be not a full weekly series, however you can expect to see more videos on this. This code will be on our GitHub and you can access that in the description. In the meantime, while you wait for the next tutorial of this series, you can watch our Python beginner to expert tutorial, or you can watch our Unity tutorial series. We have a Unity concept series. We have also a project-based Unity series where we will guide you through making a game, step by step. Thank you for watching and goodbye.